This is the quarterly plan video for collaborative code competitions. So last quarter, we managed to create a modified version of a system that we developed previously called SPP, in which locus of control among participants was switched on keystrokes in a pair programming context. This was designed to measure the types of effective collaboration that take place when two participants work together to solve challenges under SPBK, which is strict pair programming on keystrokes, and the types of engagement that take place when two participants work together to solve challenges under SPBK. The fun that measures, or we also tried to measure the fun that takes place as a result of players switching off control based on randomized keystrokes. Last quarter, our design arguments were that switching locus of control on short intervals forces each participant to collaborate in a form that promotes learning and maintains engagement in the task. We also thought that randomizing keystrokes would add an element of chance, which would foster fun while working on the task. And to measure our claims, we recorded testing sessions against treatment and control groups, which were SPP versus SPPK, and coded for interactions among users, which signified known methods of effective collaboration. The results were we were not able to demonstrate that randomly switching locus of control on keystrokes promoted fun. We were, however, able to demonstrate that switching locus of control facilitates greater collaboration between novice and intermediate programmers.
So the project goals from here on. The goal of our project is to scaffold collaboration, engagement, and learning among novice programmers. Our project is motivated by the lack of engaging resources available for novice programmers who wish to learn how to code. And our goals this quarter are to modify our SPPK system based on literature regarding collaboration, competition, and engagement, specifically in a classroom setting. We want to prepare and run a study with DTR students to test a system which promotes collaboration, competition, and fun. We want to refine that study and run a new one in this quarter, and then prepare a new study to be run in an EECS 330 class. If successful, the work we do this quarter would provide an engaging way for novice programmers to learn computer science concepts, establish a framework for those interested in creating engaging collaborative educational games, and it would provide a schema that future researchers could use to evaluate the efficacy of their own collaborative systems. Our design goals. Our user problem is that novice programmers are interested in learning computer science concepts, but they don't have an engaging platform through which they can do that. We want to incorporate competitive and collaborative features into our system to afford greater engagement and learning for novice programmers. Our design process is informed by literature and prior art in collaborative games, including digital and board games. And we plan on testing our system first with students in DTR, then later with students in the intermediate level EECS class, like EECS 330. So our technology goals. Our technology at the end of the quarter will be a collaborative educational text editor that affords competition through coding challenges. At the moment, as you can see by the diagram, it is using Glitch to run our backend, which has Node.js and ShareDB as significant libraries for running the backend. And then on the front end, we have CodeMirror for the text editor and ShareDB again to do the operational transforms. Our research goals. The research questions we hope to answer this quarter, they include how do we leverage mechanisms of effective collaboration and gamification on coding challenges? How can we scaffold for mechanisms of effective collaboration which are known to promote learning and engagement among novice and intermediate programmers? The reason why these questions are important to focus on right now is because leveraging mechanisms of collaboration and gamification will allow us to focus on producing an engaging learning experience. And scaffolding mechanisms of effective collaboration will help facilitate learning in our system. The current hypotheses that we have is that competition will promote fun in our system between novice programmers. We also hypothesize that switching locus of control promotes collaboration with novice programmers, and also that collaboration facilitates both engagement and learning, which is something that we identified in literature. So we will confirm or reject our hypotheses by testing our system with novice programmers in a classroom setting. That's it.